Okay, in example number 2, we want to find the inverse of a cubic function. So how do we go about finding an inverse? Well, given a polynomial function, we want to find the inverse of the function by restricting a domain in such a way that the new function is 1 to 1. Now the first step is to replace f of x with y. Step 2, we're going to interchange x and y, and then we're going to solve for y and rename the function f inverse of x. We want to be able to find the inverse of the function f of x equals 5x cubed plus 1. This is a transformation of the basic cubic toolkit function. And based on our knowledge of that function, we know it is 1 to 1. Solving for the inverse by solving for x. So the first thing we're going to do is we're going to replace f of x with y. So the first step is y, which is equal to 5x cubed plus 1. The second step is then interchanging x and y. So now we have x, which is equal to 5y cubed plus 1. And now step 3, they want us to be able to now solve for y. So the first thing we want to do is we're going to subtract 1 to both sides, so we get 5y cubed, which is equal to x minus 1. And then divide by 5, so we have y cubed, which is equal to x minus 1 over 5. But then in order for us to solve for y, we would have to take the cube root of both sides. So we end up with our inverse, and our inverse, f inverse of x, is going to equal the cube root of x minus 1 over 5. Now, look at the graph of f and then f inverse. We're going to notice that one graph is the reflection of the other about the line y equals x. And this is always the case when graphing a function and its inverse function. Also, since the method involved interchanging x and y, notice corresponding points. If a and b is on the graph of f, then b and a is going to be on the graph of its inverse. Since 0, 1 is on the graph of f, then 1, 0 is on the graph of f inverse. Similarly, since 1, 6 is on the graph of f, then 6, 1 is on the graph of its inverse.